Hello and thank you for joining me in another exam walkthrough for Edexcel Higher Tier. This one's going to be paper 1 from November 2021. I'll show you the solutions to all questions, and if you've used a different method to the one I've shown, it's not to say that your method is wrong necessarily, just that I can't show you every single method for every single question. Otherwise, time would run out very quickly indeed, as would your patience with the video. So I'll get straight to it now. Let's have a look together at question number 1. So question 1, part A, was a decimal multiplication problem. We needed to work out 3.67 multiplied by 4.2. So I'm going to show you 3 different ways for this one. So the first method, which was just called method A, is a column method, and in my opinion this is like the traditional old school method, probably because I was taught this one first, so I've got more familiarity with this one than the others. So it looks something like this. Typically you write down the smaller looking number at the bottom, the bigger looking number at the top. Notice with these numbers as well, I've removed a decimal for each. I'll come back to that in a moment. I'll try to explain to you clearly where we put the decimal place back in. So having set it out like this and lined the numbers up correctly, we do 2 multiplied by 7 first. 2 times 7 is 14. So we write down to 4 and carry 1 across. Next we do 2 multiplied by 6. 2 times 6 is 12. Plus this carried 1 is 13. Then lastly with this 2, I take it and multiply it by the end 3. 2 multiplied by 3 is 6, plus this 1 I've carried is 7. I've now multiplied by the 2 by all numbers above it, so then I move on to the 4. This 4 represents 40 for 0, so I include a 0 before I start the multiplication of the 4. So now I do 4 multiplied by 7. 4 multiplied by 7 is 28, so I write down the 8, carry 2 over. Next we do 4 multiplied by the 6. 4 multiplied by 6 is 24, plus this 2 I'm carrying is 26. And finally we do 4 multiplied by the 3 above it. 4 multiplied by 3 is 12, plus this carried 2 gives us 14. We now add these big blue numbers you see, not these little ones, because those are the ones we use for carrying. So we just add these up in a line using column addition, and then we've got the final answer. So 4 plus 0 is just 4. 3 plus 8 is 11. So put 1 and carry another 1. 7 plus 6 is 13, plus this carried 1 gives 14. 4 plus this carried 1 is 5. And finally that 1 on its own is just 1. So our answer looks like, but actually isn't, 15,414. So why isn't that the final answer? Well, it's because of these decimal places. So in the question we had 2 digits coming after the decimal here, and an extra 1 digit here coming after this decimal. So in total we had 1, 2, 3 digits coming after the decimal. We need exactly the same case in our answer. So we need 3 digits to go after the decimal, so we need this 4, that 1 and that 4 to come after, so the decimal goes here. So the answer is 15.414. Now question 1a using a different method, the box method. The box method looks like this. This used to be widely used in schools. It's probably not quite as in fashion as it used to be, but this is a method you've probably seen before, so feel free to use this one if it's the one you prefer. So we can do the boxes in any order. So let's do this one first. 3 times 4 is 12, then just add on the zeros. So 1, 2, 3, 1, 2, 3. 40 times 60, well 4 times 6 is 24. Add on these 2 zeros. And finally for this top line, 40 times 7 is 280. 4 times 7 is 28, add on the 0. Next line, 300 times 2 gives 600. 2 times 60 is 120. 2 times 7 finally is 14. We now add up these numbers in any order we want to. So I don't particularly like this method because it's quite a bit of adding up at the end. But anyway, if I add up these first, that gives me, well, 2,680 of these N2 together. So that gives us 14,680. So I'm just shortcutting here how to add these up. 14,680. if you added those together. And then, if you add up these ones under here, 600 plus 120 plus 14, that gives a total of 734. Then, like before, if we just add these two rows together, you'll see that the numbers are the same, 14, 680 and 734, and so in the same way, we'd get the same final answer once we added it all together. Again, we would have got 15414, put the decimal in like we would do before, and then it's 15.414 once we've added these two together. Final way of explaining, in my opinion, part A is method C, the Chinese method or the lattice. This is my favourite one, and it looks something like this. We write out the digits of each number, so 367 is 3 digits, 3, 6, 7, hence the 3 columns, and 4.2, again we remove the decimal, call it 42, that's 2 digits, so we need 2 columns. Now we just multiply each number, what's above the box, by what's to the right of the box, and we split each square into a diagonal. The tens goes at the top, the units goes at the bottom. So it's clear once we try some. You can do the boxes in any order. So for example, this box here, 7 is above, 4's to the right. So in this box we put 7 times 4, which is 28. So 2 tens, 8 units like so. This one down here is 7 multiplied by 2, which is 14, 1, 4. This box, 6 multiplied by 4, 24. This one, 6 multiplied by 2 is 12. This one, 3 multiplied by 4, again is 12. And this bottom box, 3 multiplied by 2 is 6, which is 0 tens, 6 units. We now add these numbers up going diagonally down. So just that 4 on its own, then we add up the 8, the 1 and the 2. Then it's the 4, 2, 1 and 6. 2, 2 and 0 we add, and then finally at the end we just add up that final one. So doing this, starting from the right, 4 on its own, well that's just 4, 8 plus 1 is 9, plus an extra 2 is 11, so put 1 down, and again in the same way we're going to carry 1 over to the next column. 2 plus 4 is 6, plus 1 is 7, plus the carried 1 is 8, plus this 6 is 14, so again put the 4, carry 1 along. 2 plus 2 is 4, plus 0 is still 4, plus 1 is 5. Then finally, just 1 on its own gives us 1. So we have 1, 5, 4, 1, 4. And again, in the same way, putting the decimal back in, we've got 1, 2, 3 digits after the dots in our question. So again, we need 1, 2, 3 digits after the decimal dot in our answer. So the decimal goes here. It's 15.414, just like we had before. We can now have a look at part B. Part B, work out 59.84 divided by 1.6. Well, the way I'd suggest we think about any division, in fact, is as a fraction. All a division means is it's the first number, 59.84. How many times can you fit this final number into that one? It can be written as a fraction like this. All a fraction means is the top number divided by the bottom number. What I'm going to suggest we do first of all is to get what we're dividing by into a whole number. Dividing into a decimal is quite hard as it is, so at least be dividing by a whole number. So multiply this bottom number by 10 is my suggestion. But to keep the fraction equivalent, multiply this one by 10 as well. Whatever you do to the top, you need to do to the bottom. So 1.6 times 10, we just move the decimals one to the right, that becomes 16. And this one, if we move the decimal to the right one place, becomes 598.4. Now, you could, if you want to, try and half those numbers if you wished. I'm going to show you how to use the bus stop dividing by 16 straight off. Now, if you're dividing by a fairly awkward number, like this isn't a number between 1 and 10, a little tip I'd suggest is to do the times table of a number you're dividing by just down the side of your page. So 1/16 is 16. 2 lots of 16 is 32. Add another 16 is 48. 64. 80. 96. I'll do the first 6, then I'll see if we need any more. So that's 1, 2, 3, 4, 5, 6. That's up to 6 times 16. The number you're dividing by goes first using this bus stop method I'm going to show you. And the number you're dividing goes inside the bus stop, which is 598.4. And make sure you've got a decimal up here so it's lining up with the decimal in the number you're dividing. First of all, we ask ourselves, can 16 fit into 5? Obviously not. 16 is far too big for 5. So 0/16s fit into 5. That 5's not been used, so the remainder is 5, which will move on to the next digit. So that's 9 we now think of as 59. How many times does 16 go into 59? This is where this list can help. 1, 2, 3/16s is 48, so I can fit 3/16s into 59. 3/16s is 48, which is still 11 away from the full 59. So we've still got 11 left to carry over. So that 8 is thought of now as 118. How many times does 16 go into 118? Well, at least 6/16s do. So we need to go up to 7/16s. So if we add another 16 onto 96, that would give us 112. So clearly we can see here that we can fit 7 lots of 16 into 118. 7 multiplied by 16 is 112, which is still 6 away from the full 118. So the next remainder is 6. Finally, how many times does 16 fit into 64? It fits in 1, 2, 3, 4 times. 4 times exactly, so we can stop. In other words, the answer to 59.84 divided by 1.6 is 37.4. Question 2 is a Venn diagram question. E stands for everything in the Venn diagram. So E, everything in here needs to be all the even numbers less than 19. So it couldn't be a bad idea to write out all the even numbers that are less than 19. So we've got 2, 4, 6, 8, 10, 12, 14, 16 and 18. So all of these numbers need to go in here somewhere. So all the numbers in A are just 6, 12 and 18. The numbers in B are 2, 6, 14 and 18. So what numbers do we see in each list? Well, in A there's 6. There's also 6 in B. So because 6 is in A and B, we put 6 in the overlapping section where circle A overlaps with circle B. In the same way, 18 is in each list. So circle A has 18 in it, as does circle B. So we can put 18 in the overlap, which includes both circles. The other numbers don't overlap. So the A, which we see here, is only in circle A. So we put the 12 in circle A on its own. We've now done all of region A. We've put all the numbers in, so we don't need to do any more with this one. Circle B, though, we need to include a 2 and a 14. So the 2 and the 14 go here and here. So we've got most of the numbers less than 19, all the even numbers less than 19, but there's still a few which we've not got yet. So we've got the 2, so we can cross off the 2. I've got 6, cross off the 6. I've got 12, so cross off 12, and I can cross off 14 and 18 as well. So the other numbers, which still need to be included in this Venn diagram, are 4, 8, 10, and 16. 4, 8, 10, and 16 weren't included in set A or set B, but they still need to be included in the Venn diagram. So they go outside of the regions A and B, but inside of the overall rectangle, just on the inside edge. So we can just write down here in any order, 4, 8, 10, if you want to put one up here you can do, just for the hell of it, 16. And that's the Venn diagram question completed. Question 3. Some mixed numbers. So we need to work out 4 1/5, take away 2 2/3, and we need to give the answer as a mixed number. So first what we need to do is to convert these into top-heavy fractions. So I'm going to rewrite this just so the numbers are a bit clearer. So what we do first of all is we need to change 4 1/5 into just so many fifths. So fifths here, so the denominator we still keep as 5. So how do you work out what the numerator is going to be? Well, what we do is we multiply the 4 by the 5 and then add on the extra 1. So 4 times 5 is 20, plus this extra 1 gives us 21. And then we're going to take away from that whatever 2 2/3 is as a top-heavy fraction. So here, do the same process, take the whole number, multiply by the denominator, 2 times 3 gives us 6, then add on this 2 to give 8. So we need to work out 21 over 5, take away 8/3. And to do that, we need to have a common denominator. Now, there's a few different ways of doing this, but the way I prefer to do it is to think of it as a cross, cross, smiley face. So we times each corner by the opposite corner, cross, cross, and then smiley face, because we're going to end up multiplying the denominators together as well. So this top corner here, 21, whoops, I'll change that to a yellow actually. 21 multiplied by 3 gives us 63. So we've got 63 here. 5 times 3 means the denominator changes to 15. So I'm taking away from that. I then do the 8 multiplied by the 5. 8 times 5 gives 40. So I'm going to take away 40 15ths. Now the bottom numbers are the same, means we can leave them as 15ths, and we just look at the tops. So we just now do 63 take away 40, which gives us 23 over 15. And we're almost done now, but because we want our answers a mixed number, the final step is to ask how many times does 15 fit into 23. The answer is once. Then the remainder, how many are left over, we just do 23 take away 15. In other words, 15 is still 8 away from 23. And that remainder we write as the numerator in the fraction part of the mixed number. So our final answer is 1 8/15. You'd also check as well if this fraction simplifies. This one doesn't, and so we leave it like that. That's our final answer here. Question 4 is about Tamara's and Raheem's house. So we're told 2 different houses, 2 different time periods. So what we're trying to do here is to work out at the end of 2019 whose house had a greater value. You must show how you get your answer. So we've got Tamara's house, which was £220,000 to start off with. In 2019, it decreased by 20%. So first of all, let's just consider Tamara's house. So for Tamara, it's gone down by 20%. So the house is worth £220,000. So always start off with thinking about, before anything happens to an amount, you always have 100% of it. So for Tamara's house, 100% of its value is 220,000. So next, we need to think about how we'd work out what it would be if it would decreased by 20%. So what I'm going to suggest we do is to think about it in terms of if 20% comes off, then 80% remains. So we need to find 80% of the original value. In other words, the original 100 minus, because it's a decrease, 20%. So if we've got 100%, what we could do is work out, for example, what 10% is. To find 10%, we can just divide both sides by 10, which looks like here just cancelling off the end 0 because both numbers are whole. So 10% is 22,000. Then to get to 80%, we can just multiply the 10% by 8. So then if we multiply by 8 on both sides, that'll tell us what 22,000 times 8 is, what the price for a house is in 2019. So all we need to do here really is do 22 multiplied by 8. So 22 times 8. 8 times 2 is 16. 8 times the other 2 is 16, plus we carried 1 is 17. So that's 176. Add on the zeros. 0, 0, 0. So Tamara has a house worth £176,000 at the end of 2019. We can now compare this to Raheem's house, which was 160,000, but then it's gone up by 30% by the end of 2019. So similar process, let's think about what Raheem's house must be worth. So for Raheem's house, it's an increase, so it's gone up in value. Before anything changed to its value, it was 100% of itself. If it's increased, it's gone up by 30%. So we take the original 100 and add on 30. We want to find 130% for Raheem's house. So again, 100% of Raheem's house price was £160,000. That's the original value. So what we could do with doing here, oops, almost forgot the end 0, we can do with working out what 30% would be, where we can add it on to the initial 160,000. Well, 10% we can find in the same way as we did before, just divide both sides by 10. 10% would be £16,000. Then if you multiply that by 3, to get 30%, we can see that Raheem's house, 30% of its value was £48,000. 16 times 3 is 48, add on the zeros. So Raheem's final price of 130% is the initial 100% plus this extra 30%, which is 48,000. So if we add these two totals together, 160,000 plus 40,000, well, that gives us 200,000. Then plus on this final 8,000, it comes to £208,000. So if we compare the 176,000 to Raheem's 208,000, we can therefore see that Raheem's house had more value. Raheem had, or has, the most valuable house, or at least he did at the end of 2019. Question 5 is a ratio question. For these, I'd almost always suggest to just do a table of values, but I'll come to that in just a moment. We're talking about stickers. So Rosie, Matilda and Ibrahim have some stickers in the ratio 4 to 7 to 15, respectively. Ibrahim, it says, has 24 more stickers than Matilda. So let's run with this idea first, and as I said, let's just make a table of values. So Rosie, Matilda and Ibrahim, then a total column, but because we can see here we're talking about differences between one person and the other, it might be worth including an extra column just called difference. So let's just populate with information, then we can tackle the last bit of the question when we come to that. So first of all, Rosie, Matilda, Ibrahim is 4, 7, 15. That gives us a total of 4 plus 7 plus 15, which comes to 26. And the difference in between Ibrahim and Matilda, because this is what it's mentioning here, is actually 24. But if we actually look at the difference in between Ibrahim and Matilda currently, 15 take away 7 is 8 lots. So that difference of 8 lots in between Matilda and Ibrahim must actually relate to 24 stickers. So we need to scale up these numbers. So how do we go from 8 to 24? In particular, so what do we multiply 8 by to get 24? Well, we can do 24 divided by 8, which tells us it's 3. And to keep the balance correct, we multiply all other values in this ratio table by 3 to get our final row. So Rosie, 4 times 3 has 12 stickers. Matilda, 7 times 3 gives 21 stickers. Ibrahim, 15 times 3 is 45. And if you want to, 26 times by 3 would come to 78. So the actual question's talking about comparing Ibrahim and Rosie. Ibrahim has more stickers than Rosie. So Ibrahim has 45, we found out. Rosie has 12. So Ibrahim has 45, take away 12. 5 take 2, 33. 4 take 1, 33. So Ibrahim has 33 more stickers. And that's your final answer. So Ibrahim has 33 more stickers. And that's the question sorted. So how many more? Answer 33. Diagram shows a prism. It's a triangular prism because the front and back is triangular. The cross-section, like it says, is right-angled. The base of a triangle has length 5. The prism has length 25. The volume 750. Work out the height of a prism. Well, it mentions volume here. So what we need to do first of all is remember this formula. The volume of any prism is the area of the end, or put technically the area of the cross-section, multiplied by the length. So the volume of the prism, we can highlight that. That's 750 because we're told it. We're also told that the length is 25. So we can add this in. So the volume of a prism, 750, equals some value, which is obviously going to be the area of the end, multiplied by 25. So we can rearrange that to find the area of the end bit, the area of a triangle. So the area of the end, in other words the area of this yellow triangle, which is coming along now, can be solved by rearranging this. So therefore, area of a triangle, we want to get the area of a triangle, so we want to have the area on its own. We can rearrange this by dividing both sides by 25. So the area of the triangle will be 750 divided by 25. 75 divided by 25, you can fit 3 25s into 75, pop on the 0, gives us 30. So the triangle is 30 squared centimetres, but we want to work out the height of it, call it h. So the area of a triangle, should know it's the base, which is 5, times the height, which we've labelled as h, all divided by 2. That's how we find the area of a triangle. But we now know that area is 30 because we worked it out by rearranging this. So all we need to do now is to rearrange this new equation to find what the height of it is. So I want to have h as a subject, to have h on its own. So I'd suggest to get rid of that dividing by 2 by multiplying both sides by 2. We then get that 5 times h, that dividing by 2 has disappeared, will equal 30 times 2, which is 60. So therefore the height, final step of rearrangement, to go from 5 h's down to just 1 h, we can divide both sides by 5. So the height's going to be 60 divided by 5. How many 5's in 60? That gives 12. And the units, of course, are centimetres. So the height of this prism is 12 cm. Question 7. We've got a diagram showing a cube with edges of length x centimetres and a sphere of radius 3 centimetres. And importantly, we're told the surface area of the cube is equal to the surface area of the sphere. So let's lead with this. The surface area of the cube, compare that to the surface area of the sphere. So for a cube, obviously one face is just going to be the length times the height, the area. So for a cube, one face of it is just going to be x times x, which is x squared. So if I just take this side face on the left, to work out the area of this blue shape, the blue square side I'm colouring in, it'd be the base, which is x, times the height, which is x, because it's a square. So one side of it will be x squared. How many sides does a cube have? It has 6 sides, like a dice has 6 numbers. So the surface area of the entire cube is x squared plus x squared plus x squared plus x squared 6 times. The surface area of the cube is going to be 6x squared. So that's the first bit of information we can use. That's probably the easier bit. So 6x squared, we're told, is equal to, so that will equal the surface area of the sphere. Luckily, we have a formula. So for this particular sphere, the surface area is 4 pi r squared. So that's 4 times pi times r, which is the radius, which is 3. So that's going to be times by 3 squared. So 4 pi times 3 squared, do the indices first. 3 squared means 3 times 3, which is 9. 4 pi times 9. If you bought 9 packs of 4 pies, that would be 36 pies in total. So the surface area of the sphere is 36 pi. So 6x squared equals 36 pi. We want to show what x is equal to. Now x is the side of a square, so we know x is going to have to be positive. We don't want 6x squared, we could do knowing what just 1x squared is. So to go from 6x squared down to 1x squared, we can divide by 6. If we divide this by 6, I divide by 6 on the other side. So 36 divided by 6 is 6. So 36 pi divided by 6 is going to be 6 pi. Therefore, to go from x squared down to just x, I'd have to square root. If I square root one side, of course, I do the same operation on the other. So therefore, x is going to be 6 pi all square rooted. So as you can see, our result, square root of 6 pi, is exactly the same as what we wanted to show all along, which was to show it was equal to k pi. In our particular case, the k happens to be 6. That doesn't need to be stated as such. The answer is just root 6 pi, and showing how you arrive at that with clear working, something like I've shown you here. That's question 7 finished. Let's have a look at the next one, question 8. Question 8 might well throw you off, okay? Question 8 isn't a standard looking quadratic. A standard quadratic should be equal to 0. Here I've got the x squared equal to 5x and 24. So let's get everything onto the left-hand side. So first of all, make that 5x disappear by taking away 5x's on both sides. On the left, I'd then have x squared minus 5x. On the right, I've just got 24. My target, though, is have it all equal to 0. So to get rid of that 24, I can just subtract 24 away. If I take 24 away on the right, of course, I need to do the same on the left. So then we get x squared minus 5x minus 24 equals 0. We now need to think of two values. We need to think of two values where the two values, if we times them together, gives us this n number. So what number, when you times it by another number, gives us minus 24, but when I add the two numbers together, which I'm trying to work out, it needs to give me this minus 5. First of all, if we're timesing numbers together and the answer comes out as being negative, we know for definite one of the values has to be a negative. However, if both were negative, a negative multiplied by a negative would make it positive. So we're looking for one number which is a positive number, another number which is a negative number. So it's best to think about just 24. Think of two numbers at times to give 24. We've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then that's pretty much all the pairs we can have. So which of these values can we make a negative so that when we add them together we get minus 5? Hopefully you'll see that 3 minus 8 would work, because 3 times minus 8 is minus 24, and 3 take away out is minus 5. So our values are 3 and minus 8. Then all we need to do is to put these values into brackets like so. To get x squared, we need to have an x in one bracket and an x in the other. So just simply say in one bracket we need a positive 3 and the other one minus 8. So one bracket times another gives us 0, that means one of these brackets has to be equal to 0 itself. Because the only way you get 0, if you're multiplying two values together, is if one of those values is 0. So maybe x plus 3 is 0. If x add 3 is 0, x would have to be negative 3. Or it could be that this bracket's equal to 0. If x minus 8 is 0, then x would have to be 8, because 8 take 8 is 0. So once you get to this stage, you just take these values and switch the signs. Plus 3, x is minus 3, x minus 8, x equals plus 8. That's question 8 wrapped up. So let's move on without further ado. Many parts to question 9. It's all about laws of indices. So the first question, write down the value of 7 to the power 0. Whoops, that was a mistake. So anything to the power 0, you need to just know is 1. It's one of these facts of life. 7 to the 0, 10 to the 0, pi to the 0. Your bed to the power 0 is 1. So this is just simply 1. Know that fact all day long. Part B, find the value of 3 times 3 to the 6 times 3 to the minus 6. The big numbers are all the same for all 3's. That 3 doesn't have a little number next to it. If it's just a number on its own, it's the same as saying it's to the power 1. When we're multiplying numbers where the base numbers, these big numbers, are the same, and we want to work out the new overall power, we just add these powers together. So we've got 1 plus 6, and then plus minus 6. That equals 1. 1 plus 6 is 7, take away 6 is 1. So therefore, the answer to this is just 3 to the power 1, which of course is just 3. So first one's 1, part B, the value is just simply 3. This one here, find the value of 2 to the 4. 2 to the minus 4, sorry. I'd suggest to think of this as what 2 to the 4 is first. 2 to the 4 means 2 times 2 times 2 times 2, which is 16. Once you work out a power which is positive, the negative version of that is the reciprocal of 2 to that power when it's positive. So if 2 to the 4 is 16, 2 to the minus 4 is 1 divided by 16. So the value for part C is 1/16. You could give it as a decimal if you really wanted to. That's much harder. Just leave it as a fraction. Part D, find the value of 27 to the power 1/3. If we've got a power which is a fraction, the bottom number is essentially what type of root we're doing to the big number. And the top number of the fraction is what power we raise the answer to afterwards. So we do this bottom number first. Because it's a 3, we cube root 27. So cube root 27 first, and we do that because the bottom number is 3. So what number, when you times it by itself 3 times, gives you 27? Well, that's 3, because 3 times 3 times 3 gives 27. Then we do 3 to the power of a top number, so we're going to do 3 to the power of 1, which is just, obviously, 3. So part A is 1, part B is 3, part C we had 1/16, and finally part D of question 9 is simply 3. Question 10 is about a diagram made from 6 identical squares. We're told the total area of this particular shape. We need to estimate, not exact, find an estimate for the length of one side of each square. Give your answer correct to the nearest whole number. So what I'd suggest we do is just think about the area of one square first, because we're told about the area here, and then we can go from the area of the square to the length afterwards. So the whole shape is 6 squares, and so 6 squares must have an area of 5,406. So if the area is just one square, to go from 6 squares down to just 1, we could divide the total area by 6 to find the area of one square. So best way to divide, in my humble opinion, is using the bus stop method. So how many 6's fit into 5,406? Just taking it number by number. So 6 into 5 does not fit, so that 5 is still left over. That 5 is a remainder, which we shove on to the next number. So 4 now becomes 54. So how many times does 6 now go into 54? Well, 6 times 9 is 54, with no remainder. So that 0 has no remainder to put next to it. So how many 6s fit into nothing? Well, 6 can fit into 0 0 times, because nothing can fit inside 0 because there's no space. So the remainder is 0 because there's nothing there to begin with. So that 6 stays as 6. Final one, how many times does 6 fit into 6? That's 1 with no remainder, and that's the last number, so we're done. So each square must be 901. Each square has an area of 901 cm squared. So the area of each square, if I didn't know it, I could say, let's say the length of a square, for example, is x. If the length of it is x, the length is the same as the height of it as a square, so that would be x times x to find the area. So the area of each square would be x squared. So if I call that x squared is 901, in other words, each little square has an area of 901. We just need to remember now, how can we go from squaring something to just the value itself? What's the opposite of squaring a number? Well, the opposite of squaring a number is to take the square root. So if x squared is 901, then the length of one side, therefore the length x, will be the square root of 901. What on earth times by itself gives us 901? That's just really hard, but then we need to remember it's an estimate. So we're allowed to round the numbers very so slightly. 901, I can't think of a number myself. Honestly, I don't know what number times by itself gives us 901. However, this number is begging to be rounded. 901 is just so close to 900 that I can say it's about the same as the square root of 900. Now this is much easier. If I forget these zeros, I can think of a square root of 9. The square root of 9 is 3, because 3 times 3 gives us 9. Therefore, the square root of 900 would actually be 30 times 30. So our approximation is 30. Part B, is the answer an underestimate or overestimate, and give a reason? Well, the actual length of each square would have been the square root of 901. 901 is bigger than 900, so the actual length, the square root of 901, would actually be slightly bigger than the square root of 900, which is 30. In other words, the actual length will be a tiny bit bigger than 30. So what we've done is made our estimate slightly smaller for what the actual answer should be, so therefore this is an underestimate. It's an underestimate. The reason was because I rounded the area of each square down from 901 to 900 to make the calculation easier. So part A, 30, part B, an underestimate with a valid reason like I've put here. Question 11, we have an area mixed in with algebra. So we're told here that all measurements are in centimetres and that the area of rectangle A is equal to the area of rectangle B. So this rectangle A, the area of this one is the length of it times the width, so 2w plus y all multiplied by 6. So for this one, it's going to be the area 6 lots of 2w plus y. So 6 times 2w is 12w, and 6 times y is 6y. So that area is 12w plus 6y, whereas rectangle B the area of this one, same formula, it's still the length times the width, but this time it's going to be 7w times by 3y plus 6. And again, if we expand this out, 7 times 3 is 21, w times y is wy, and then finally 7w times by 6, 7 times 6 is 42, so 7w times 6 is 42W. We're told though the area of A is equal to the area of B. So the next step is to put these into an equation. So 12W plus 6Y, which is the area of A, must be equal to the area of B, which was 21WY, almost made a mistake, plus 42W. Find an expression for Y in terms of W. So we want to make Y the subject. Essentially, we want a Y equals something. So we want it all in terms of W. So we need to get Y on its own on one side of this equation so that we can then, afterwards, isolate it and work out what Y is in relation to everything else. So we need to get Y on the same side of the equation, whereas here we've got Y's on both the left and the right. What I'm going to suggest we do, we can get rid of these 6 Y's on the left by taking them away. So we need to take them away on the right hand side as well. Then we'd have 12W equals 21WY minus 6Y plus 42W. Again, we can get the W's onto the same side. We can make these disappear on the right by taking away 42W. If we take away 42W on the right, I need to do the same on the left. So the left becomes 12W's take away 42. 42 take away 12 would be 30. So 12 take away 42, the other way around, would be minus 30. So we're going to have minus 30W equals 21WY minus 6Y. Now this here we can factorise out a W. So we're going to leave, so it can factorise out the Y. So we're going to leave the W on the outside, and then we can think of the numbers as well. So 21 and 6, both of these numbers are in the 3 times table. So I can actually factorise out a 3. And also a Y is in each group, so I can factorise out a Y. So I've got 3, I want to have 21. I need to times 3 by 7 to get 21. And because I want to have a W here, I need to multiply by a W there as well. Minus sign, so stick a minus sign in. I've got 3Y, I want to go to 6Y. So I need to multiply the 3 by the 2 to get the 6. That's the next step. Now, I can see here that I can divide both sides by 3, because both 3 and 30 are multiples of 3. So if I divide both sides by 3, I am then going to get that minus 10W equals just 1Y now, 7W minus 2. And the final step to have Y on its own is to divide both sides by the bracket 7W minus 2. So therefore, we're going to have Y equals, we don't need to put Y equals, an expression doesn't need, and strictly speaking doesn't have an equals sign. But then we'd have minus 10W all over 7W minus 2. Or we could have had, instead, if you multiply both top and bottom by minus 1, we could have also had 10W over 2 minus 7W. So both of these answers are equally valid. So either minus 10W over 7W minus 2, or this answer here, 10W over 2 minus 7W. Question 12, we've got a cumulative frequency diagram to plot. So we've got the information and the cumulative frequency. Part A, we need to draw on the cumulative frequency curve. Now, when we're doing cumulative frequency curves done from the table, we always have to plot from the endpoints. So we're always taking these numbers and plotting using 5, 10, 15, 20, 25 and 30. We never plot from the first numbers. So the first one, height of 5, cumulative frequency 4, means you go along 5 and up to 4. So the first point is going to be here, 5, 4. Next point is going to be 10 along, 11 up, which is here, 15, 24, add that. 20, 34, 25, 38, and the last point is 30 and 40 up. And you then need to do a curve that goes through all of these points. So try and draw through all of these points with a smooth curve if possible. If you really can't, doing it with a straight line might get away with some marks there. Sometimes the examiner will allow you to have full marks, but please try, if you can, to do a smooth curve for all of these points, something a bit like this perhaps. So that's the cumulative frequency graph, and you do need to have a curve going through all points. So that's part A. Part B, we need to use this curve now to estimate the median height of the plants. Well, median means halfway. So median is a middle value. There's 40 plants, so the middle plant would be the 20th. So we go to 20 and read along from 20 all the way until we hit the line. Once we hit the curve, we then go down and read off the appropriate value, which you can see here is, on mine at least, 13.5. So 13.5 would get full marks, but because you may have drawn your curve slightly different to mine, and it is an estimate, any answer in the range between 13 centimetres and 14 centimetres inclusive would be enough to score full marks, so long as you've done a curve and you've evidenced that you've used your curve to get your answer, which needs to be in between 13 and 14 centimetres. Question 13 is one of these where you have to evaluate somebody else's attempt at a question. In this case, the person is Ted. So he's trying to go from a recurring decimal to a fraction. So you need to know the method in order to answer this question. So Ted here is starting off with x, which is 0.43 recurring. Next to Ted's method, I'm just going to do what I'd suggest Ted did. So the best way of comparing if a method is right would be to work through how you do it, assuming yours is correct, and then when your method goes different to the other person's, have confidence in yourself. Where you're different will be where you're right and where Ted may have gone wrong. So his first step, I would suggest we do the same, but we write down x as a recurring decimal with a few more digits after, so you can see the pattern. So 0.43 recurring means 0.4343 again and again and again. 10x is multiplied by 10, that's not a bad move. So 10x is 4.34 recurs. He's not wrong there either. So 34, 34, 34. Make sure the numbers are in line. And you'll see here that if we attempted 10x take away x, then we'd be in trouble, because if we did 10x take away x, we'd have 4 take away 3, which would be 1. Then 3 take away 4, we'd have to borrow. So we wouldn't have the numbers cancelling nicely. So if we attempted to do a subtraction, you don't need to show this to the examiner, but what you need to do is to understand where he's gone wrong. Essentially, these values here would not cancel. And the method only works when you multiply by 10 enough times so that you get cancellations. So multiplying by 10x isn't enough. So what Ted should have done would have been to actually just multiply by 10 again. That would have given him 100 x's, which would be 43.4343, and so on and so on. And then if we do that, then if we compare the 100x line and the 10x line, the top and the bottom, and we did the bottom one take away the top, then you would see that actually the numbers would cancel nicely. So that's what he should have done. What he didn't do is to multiply by 10 again. He should have gone from 10x to 100x. That was his error. You can't do 10x take away x because there's no cancellations. So that's why he's wrong. In terms of you explaining it, you'd have to put something like this to the examiner. So essentially you can't do 0.34, where the 0.34 is 0.34 recurring, minus 0.43. So you can't do that because there's no cancellations. What he needed to do would be to multiply by 10 again to get 100x, and then do 100x take away 1x instead, rather than try and 10x take away 1x, which is impossible using his method. So that's his mistake. That's our answer. Question 14, of a compound shape, essentially two rectangles glued together, if you like, and the total area of the shape is A cm squared. We're going to show that A, the area, is the same as this algebraic expression. So to work on a compound shape, what we need to do is to split it into easier shapes which we know how to work out. So here, I'm going to suggest that we just simply draw a line in between this top little rectangle and this bottom bigger one. So I'm going to just colour code these now, the top one in yellow, the bottom one in green. The area of a rectangle, you know, is length times width, so we can work these out next. And once we have, we can then work out the areas of the green and yellow separately and add together. So the top one, x plus 1 along by 4, that's fine, but we don't know the width of the green one. We know its length is 2x plus 6, but what I don't know here is its width. So I need to find out what the width of this one is as well. Now, what I do know is that all the way from top to bottom is x plus 11. But this bit here is 4. So the lower bit here will be x plus 11 without that 4. So x plus 11 without that 4 would be x plus 7. So as a double check, what we've got here is that's 4 plus the x plus 7 would give you x plus 11, like what we need. So now we know the dimensions of the yellow and the green, we can now work through and calculate length times width for each of them. So first of all, for this green one, it's 2x plus 6 multiplied by x plus 7. So this first one, 2x times x, is 2x squared, x times 6 is 6x, 2x multiplied by 7 is 14x, finally 7 times 6 is 42. And so the green rectangle, this one here, simplified, will be 2x squared, 6 plus 14x's is 20x's, and then finally 42. So this area here is that. And the yellow area is just x plus 1 all multiplied by 4. X times 4 is 4x, 1 times 4 is obviously 4. So the yellow area is simply 4x plus 4. So therefore, A, total area, is going to be our yellow area, which is 4x plus 4, as well as the green area of this green bigger rectangle, which is 2x squared plus 20x plus 42. So 4x plus 4, then 2x squared plus 20x plus 42. So now it's just a case of simplifying down. So the area, how many x's do we have? Well, we've got 2x squared there. 20x's plus 4x's gives 24x. And finally, just for units, 4 plus 42 gives 46. So we've shown step by step how the area is 2x squared plus 24x plus 46. The key thing here is show the working carefully, show the exam you've split it into two separate areas, show algebraically what these areas are, add them together and show you adding them together and simplifying. The examiner can't mark you down if you show clear methods like I have and then write down 2x squared plus 24x plus 46 as your conclusion, which is what we wanted to show all along. For question 15, we have to show that 4x plus 3 over 2x plus 3/5 can be written in the form ax plus b over cx, where a, b and c are integers. An integer just means it's a whole number which is allowed to be negative. So these are algebraic fractions. Best way I can explain it is to just think of these as adding together two normal fractions. So if you think of these as just two normal fractions, what would we do if we were just say, I don't know, a half plus a quarter? To add fractions together, what do we need to happen? Well, what we need is a common denominator. 2x and 5, these denominators are not the same. We need to make them the same. There's a few methods you can use to get a common denominator. The method I like to use, which I call cross smiley face is just cross multiplying each corner by its opposite corner, and then finally just times the bottom numbers, the denominators, together. And so this is going to become, at the top here, 4x plus 3 times by 5. If you just times all of this top by 5, 4x times 5 gives us 20x. 3 times 5 is 15. So this new numerator is 20x plus 15. And the new denominator, we just do 2x times by 5. So 2x times 5 is 10x. And then we do the same with the other fraction. So here, for 3/5, we're going to take the 3 and times by the 2x to get the new numerator for this one. So 3 times 2x is 6x's. So the new numerator for this fraction then becomes 6x. Meanwhile, the denominator, in the same way as before, we're just 2x times 5ing. So 2x times 5 is 10x. When the bottom numbers are the same, we leave them the same. Leave these both as 10x's. For example, if we had 1/2 plus a half, that's 2 halves. You don't add the halves together at the end. So we'll leave the numerators, add these together, but for denominators, we do not add. Keep them as 10x. For top, though, we can combine. So 20x plus 6x is 26x's. And of course, then 15. And that's our final answer. So we've shown it can be written in this form. So in our case, A is 26, not that you need to write that as such. B is 15, and C, the number in front of the x, is 10. That's question 15 sorted. Question 16, there's 3 red and 5 yellow counters in a bag. Jude takes at random 3 counters from the bag. Work out the probability that he takes exactly 1 counter. So if Jude's taking 3 counters, there's going to be 3 different pickings of counters. So first of all, the first pick can either be red or yellow. The second pick can be red or yellow, of course, and you've guessed it, the third pick again could either be a red or a yellow. So what we need to do here is to work out these probabilities for each branch. So the first pick, there's 3 plus 5, there's 8 counters in total. To begin with, 3 out of 8 are red. The other 5 out of 8 are yellow. I'm not going to write this in yellow because it won't really make it clear on your phone or computer screen. So now, first of all, let's just think about the top branch. Let's think about if just red was picked. For the second picking, if a red was picked first, there'd only be 2 reds left, and if one's been picked, there's only 7 left in total. So if red's picked first, there'd be 2 reds out of 7 left for the second picking. If 2 out of 7 are red, the other 5 out of 7 would be yellow. And again, just focusing on this very top branch, imagining you've picked 2 reds in a row. For the third pick, 2 counters have gone, there's now only 6 left. If you pick 2 reds have gone, there's only 1 red out of 6 left. If 1 out of 6 are red, the other 5, 6 must be yellow. This branch down here, if you picked a red first and then a yellow, again there'd only be 6 counters left at the end. But if we went a red, then a yellow, there'd be 1 less red, there'd be 2 reds left out of a total of 6. If you had 1 yellow, there'll be 1 yes yellow, there'll only be 4 of them out of 6. Looking at the bottom branch here, going all yellows, if we picked a second counter down here, in fact I'll get rid of that, there we go. If we picked a second yellow, there'd only be 7 counters to choose from, only 4 of which would be yellow. If 4 out of 7 are yellow, up here, 3/7 must be red. And finally, if we picked a third yellow, well, there'd only be 3 yellows left to pick from if 2 yellows were picked before, out of a total of 6. At this stage, if 3 out of 6 were yellow, the other 3 out of 6 must be red. And this final branch here is if you pick a yellow first and then a red. If you pick 1 of each, a yellow and a red, there'd be 1 yes, 1 less red and 1 yes less yellow. I'm getting tongue-tied here. So 1 less yellow would mean there'd be only 2 reds out of 6 to choose from, which would mean 4 out of 6 would still be yellows. So we want the probability takes exactly 1 red counter. So there's a few ways this can be done. So to take exactly 1 red, what could be done is he could pick 1 red, then a yellow and a yellow, or he could pick a yellow first, a yellow second, and the final pick could be a red, or he could pick, instead of that, a yellow, then a red, and then a yellow. So there's 3 different branches. So it's a probability. It could be red, yellow, yellow. Or, to work out all we add, could be the probability of yellow, yellow, red. In fact, I'll colour code this branch slightly different. I'll colour this in a pink. Or it could be this final root, which was in a purple colour. It could have it where we pick yellow, then red, then yellow. So it could be yellow, red, yellow. So first off, we just consider picking red, yellow, yellow. To work out that probability, we multiply the numbers we cross along these branches. So we've crossed 3 different fractions. We've crossed 3/8, 5/7, and 4/6. So we multiply these together. So that's 3/8 times 5/7 times 4/6. So that's the first branch. And then the probability of going yellow, yellow, and then red, which I've colour-coded in pink, that's going to be 5/8 plus 4/7 plus 3/6. So we just multiply those together and then add that result. 5/8 plus times 4/7 times 3/6. And the final one is, of course, where we go yellow, red, yellow, the one I did in the purple, this one here. So looking at the probabilities we cross along this purple branch, first of all we've got 5/8, then multiply by 3/7, which is our red one, then multiply finally by 4/6. So as you can see, it's an awful long calculation to do this, but we will be able to get it sorted. It just takes a slight bit of time. So first off here, you'll notice these denominators are all going to be 8 times 7 times 6. So what is 8 times 7 times 6? So 8 times 7 times 6. Well, 8 times 7, we could do that one first. 8 times 7 is 56. But if we multiply it by 6, 56 times by 6. 6 times 6 is 36. Carry the 3. 6 times 5 is 30, plus that 3 is 33. So the denominators are going to be 336. So first of all, 3 times 5 times 4. 3 times 5 is 15, times by 4 is 60. This other one, again out of 336. 5 times 4 is 20, times 3 again is 60. And surprise, surprise, this one, 5 times 3 times 4, again is 60. So you've got 60 plus 60 plus 60, all out of 336. Just add the top numbers, gives us 180 over 336. That's hard enough as it was. The blessing with probability is you don't need to simplify at the end. So I think we've worked hard enough as it is for that fairly nasty question, in my opinion. Leave it as 180 over 336. You could simplify, both numbers are even, but leaving it like this is absolutely fine. The chance of getting exactly 1 red is 180 out of 336. For question 17, we need to represent inequalities on a coordinate grid. And the way we do this is by considering these not as inequalities but as actual equations. So we'll come back to the inequality bit in a moment, but for now we're going to consider these inequality symbols as equal signs. So think of these ones in this way. Think of this as 2y plus 4 equals x. Think of it as x equals 3 for now. Think of this one as y equals 6 minus 3x. So to represent an inequality on a grid, it's more or less the same thing as drawing a straight line graph. But the only thing is, you need to think about what type of straight line we're drawing. Either a normal full line or a dotted line. And whether you use a full line or a dotted line goes by the following rule. It depends on the inequality symbol. If we have an inequality symbol with a line underneath, in other words a less than or equal to, or a more than or equal to sign, we do a full line. If, however, we're talking about an inequality symbol without the line underneath, a strictly less than or greater than symbol, we do a dotted line. So the way I remember this, which is a bit silly perhaps, but it does work, one of these symbols with an extra line underneath obviously takes more ink from your pen to draw. In the same way, a full line takes more ink from your pen to draw than a dotted line. So more ink, more work to do with symbol, less ink, simpler symbol. So we're going to now draw these straight lines on this grid, and then we can find out where this region will go, which satisfies all these inequalities. So first of all, the red one, 2y plus 4 equals x. The best way of getting a straight line is in the form y equals. Make y the subject. So here I'm going to take 4 away from both sides. That'll give me 2y's equals x take away 4. Then to go from 2y to just 1y, I can half everything. So this one here, I need to think of as being y equals x divided by 2. So that's half of an x, and half of minus 4 is minus 2. However, like I said, we'll come back to this idea of the inequality symbol in a moment. But first of all, let's just draw this straight line on. So the y-intercept is at -2, so it's going to cross here, and the gradient is a half because the coefficient of x is a half. That means every square we go along, we only go up half a square. So 1 unit along, up half a unit. Along 1 unit, up half a unit. That means for every 2 squares along, we're going 1 square up. So 2 squares along, 1 square up, and so on. You'll soon get the idea where the line goes. It's going to be a straight line through these points like so. And make sure it's extended upwards as well. But like I said earlier, because it's one of these symbols, we do a dotted line. So what you need to do is have your line dotted like so. Now here, this symbol was actually facing towards the right. So what we're actually thinking of here is where is y less than a half x minus 2. We want y to be smaller than this. We want y to be on the small side of this line. Y is big on the high side, y is small lower down. We want y to be lower down, not high up, so we're going to cross off everywhere higher up. We don't want all of this area up here. We want y to be lower than this line. Next, let's do the line x equals 3, making it dotted, of course. So the line x equals 3 will be a straight line cutting the x-axis at 3. So the line x equals 3 will look something like this, going through where x equals 3. But of course we want x to be less than 3. X is smaller to the left of the grid. For example, these numbers here go smaller and smaller when we move to the left. So we want x to be over here, not on the big side of 3. So because we don't want the higher side of 3, we want x to be less than 3, we're going to cross off everything over here. Because we don't want x to be bigger, we want it to be smaller than 3. So you can now see this region R is going to be somewhere down here. To narrow it down further, we just need to focus on this final inequality. Y equals 6 minus 3x. The number on its own is 6, so the y-intercept of this line would be 6, so I can plot that there. And because the number in front of x is minus 3, the gradient is -3. That means for every unit along, we go down 3 units. So 1 unit along, down 1, 2, 3. 1 unit along, down 1, 2, 3, and so on and so on. So again, you get the picture, hopefully, of where this line is going to go. It's going to go from 6 straight down through these points, like so. We then turn back to this idea of the inequality. We want y to be less than 6 minus 3x. Y is less or smaller below the line and bigger above. We're wanting y to be on the small side, so we're wanting y down here, not up there, so I'm going to cross off anything on this side of my green line. So I'm going to cross off all of this. So the only bit of this coordinate grid now which isn't blocked off is this corner bit down here. So region R is going to be simply this bit down here. Now you don't need to colour it in like I'm doing. I'm just doing so you can see it clearly enough on your display screens, whether it be a TV or a phone or whatever you happen to be using. So region R is down here like so. So follow the instructions of the question. No, it doesn't say to have to colour it in. I'm just doing that so you can hopefully see clearly at your side, but we do need to label it R, and so nice, big and clear, we need to label region R properly. So big R down here is where we're looking. And that's question 17, done and dusted. Question 18, we've got a trapezium, ABCD. We're told its area is 66, and we're told the ratio of AB, the top of it, to the length of the bottom of it, is 2 to 3. We need to find the length from A to B, which is the top bit of the trapezium. So let's just talk this through step by step. So the main thing is it's about the area of the trapezium. We're told the area of the trapezium is 66 cm squared. That should beg the question to you, gosh, what's the formula, or how do you work out the area of a trapezium? Which should then hopefully get you thinking about this. This should hopefully come back to mind. The area of any trapezium is half A plus B times H. So in plain English, I see this as add the top and the bottom together. So I see A as the bottom, B as the top. The top and the bottom are the two parallel sides. So add your two parallel sides together, half it, then times by the height. So that's what we mean by the height. It's the perpendicular distance between one parallel side and the other one. So at some point we might need to find H. Also we're told the length of AB to the length of CD is 2 to 3. So AB I'm going to label in red at the top and D to C in blue at the bottom, like so. And we don't know if this is 2 centimeters to 3 centimeters. It could be 4 kilometers to 6 kilometers. Because we don't know the exact lengths, we can make up a value x and say that, well, if AB is, say, 2x, then CD will be 3x's. So we could just introduce x as something to then solve. So let's just call this one 2x and this one down here 3x. So it does hinge on working out this h as well. But if we cast our eyes over here, you'll see we've got a nice familiar right-angled triangle. So again, if I just take this and get it separate so we can focus in on this, let's think about how we could maybe work out h. Well, it's a right-angled triangle, so we know now this is going to be Pythagoras or trigonometry. Because it's involving a side, which we know, and an angle, it's going to be a case of SOHCAHTOA. So now we just need to think, what sides do we know, and therefore which trig ratio is it we're going to use, sine, cosine, or tangent? At this point, it does occur to me that h could be potentially confusing because h can stand for hypotenuse. So I'm actually going to ignore h here just for a second, because actually h stands for hypotenuse. So for this triangle here, the hypotenuse is clearly 6. That's the longest side. The opposite means opposite to the angle in question. So opposite to that 30-degree angle is that side. That's O. So if it's not H or O, it's A. Now this side, which is the opposite, is clearly the side we want to find. The opposite side is the height. So what I want to find is O. What I do know is H. I want to find the opposite, I do it over hypotenuse. So which one of these triangles includes O and H? Hopefully you'll see here it's got to be the SO triangle. So that's what I'm going to use. Now because I want to work out the opposite side, that's the letter I either cover up or scribble out or whatever. What things are left, that tells us what to do. So the opposite side is SH. Two things next to each other in maths means one multiplied by the other. S stands for sine of the angle in question, which is 30. Pop that in brackets and then close off. And then we're going to multiply that by the hypotenuse, which is 6. And shucks, what do you know? It's a non-calculator paper, so I'm not going to go into it right now because it's a separate topic. You need to know the exact trig values. Sine 30 is one of them. You just need to know, using a few various methods mentioned in class or online, that sine 30 is actually a half. So that's 0.5 times by 6. Half times 6 is clearly going to be 3. So the height is 3 centimeters. So what we can do now is we can actually just switch out the H and pop in what H actually is. H is 3. We can now shove in what we need into the equation of the area of a trapezium, because now we've only got one unknown thing, which is this x, because we know what the height is and we know the area of trapezium because we're told is 66. So using this formula here, the area of trapezium, 66, equals half A and B are the top and the bottom, the two parallel sides added together. So one parallel side is 3x, the other is 2x. So I'm going to add those two together, 3x and 2x, and then multiply that by the height, and the height is 3. So there's a few ways of solving this, to be fair. What I'm going to do here, I'm going to make the personal decision that I'm going to get rid of that timesing by 3 by dividing both sides by 3. So I'm going to divide that side by 3 and the other. And the reason I'm doing that is because it's a fairly easy calculation in my opinion to do. So 66 divided by 3 is just 22. So 22 equals a half of 3x plus 2x. But I can simplify this bracket easily enough. 3x plus 2x's is 5x's. So now I can either multiply both sides by 2 or expand the bracket out. It doesn't really matter as long as you're consistent and apply the method correctly. I'm just going to get rid of this half by doubling both sides. That's a choice I'm going to make. So then we have 22 times 2, which is 44. That's going to equal 5x's. And the final step, dividing both sides by 5, x is going to be 44 divided by 5. And if you wanted to, it could be left like this. I'm going to show you how to do it as a decimal though. We just literally do how many 5s we can fit into 44. I'm going to do it as 44.0, so I've got some places to put the decimal points should I need. 5 into 4 doesn't go, so that 4 is still a remainder. So it's essentially we just do how many 5s fit into 44. Well, we can fit 8 5s into it. 8 times 5 is 40. 5 times 9 is 45, so we can't quite fit 9 in. 5/8 are 40, so that's 4 away from 44, so the remainder is 4. Then 5s into 40 goes 8 exactly, so 44 over 5 is 8.8. So I'm going to say that's 8.8. But because we want to work out what AB is, if I just scroll up to remind us, AB is actually 2x. So finally, so therefore AB, which equals 2x's, is 8.8 times by 2, because it's 2 lots of that. Do this whichever way you want. I'd think of this personally as 2 lots of £8.80. 2 lots of £8 is £16. 2 lots of 80p is £1.60. So £16 plus £1.60 is £17 I'm thinking so much of money, I'm putting money as a symbol. That's rather stupid. 17.6. Don't forget the units. We're talking in terms of centimetres, so AB must therefore be 17.6 cm. Question 19. Show that a plus root 12 over 5 plus root 3 can be written in the form a plus root 3 over b, where a and b are integers. This is a question which is saying, without saying it, to rationalise the denominator. So I'm going to show you the method for doing so. The main thing for these types of questions, I'm just going to write out the question again, slightly bigger, so it's clearer. We need to get rid of any surd on the bottom of the fraction. So here that root 3 needs to disappear, so we've just got a normal whole number at the bottom. The trick here, if we've got a whole number and plus or minus a surd, is we have to multiply both top and bottom by this exact same thing almost, and all we need to do here is switch the symbol. So the plus switches to a minus. If it were already a minus, we'd switch it to a plus. And to keep it as an equivalent fraction, we need to also multiply the top by 5 minus root 3. Now, on the bottom of a fraction, this is going to be the easy step. So this is actually a type of difference of two squares. So 5 plus root 3 times by 5 minus root 3, we're just going to end up with 5 squared, which is 25, minus what root 3 is squared. Well, the square of root 3 is root 3 times root 3, which is, well, just 3. So the bottom becomes 5 squared minus root 3 squared. Difference of two squares, look it up or ask your teacher. I'm not going to go into it here, but that's the method to use. It saves you lots of time, so learn it and know that method. The top is a bit harder though. So you've got 8 plus root 12 times by 5 minus root 3. You could either use FOIL, which I'm not a personal fan of, or the grid method, which I am. So you might want to do something that looks a little like this. So something like this grid. So we're just timesing everything out. So first off, 8 times 5 is 40. 5 times root 12 is 5 root 12. 8 times minus root 3 is minus 8 lots of root 3. And finally this box, root 12 times root 3 would be root 36. But because I'm timesing by minus root 3, that becomes minus root 36. So we've got a bit of neatening up to do here, because we want to get it all in terms of root 3. Here I've got root 12 and a root 36. So I've definitely got 40. 40 is a nice, easy, normal looking number. Root 12's got nothing to do with root 3 though, so I need to think how I can change that. So to simplify a surd, I try and find a factor of what's in the surd, which is a square number and the biggest one I can think. Well, the biggest factor of 12 I can think of, which is also a square number, is 4, because 12 is 4 times 3. So I'm going to rewrite this as root 4 root 3. Now at the bottom, I've got minus 8 root 3. Now that is in terms of root 3. Just give myself a bit more space here. So I'm going to leave that as it is. So minus 8 lots of root 3. But the square root of 36 is 6. So I can just make this simpler and say this is the same as saying it's minus 6. So getting a bit simpler now. 40 take away 6. Well, I can say that's 34. So I can put 34 there. Now this 5 root 4 root 3, well, the square root of 4 is 2. So 5 times 2 times root 3 is the same as saying 10 root 3. So I've got 10 root 3 there, but I'm taking away 8 root 3 over here. So finally, fully simplified down, this thing here, 8 plus root 12 times 5 minus root 3, would become 34. And if I've got 10 root 3's and I take away 8 of them, I'd have 2 root 3's left. Think of it as an x. If I had 10x, take away 8x, I'd have 2 x's. So the counting units are root 3's rather than x's, so now I'd have 2 root 3's. So on the top of the fraction, I've got 34 plus 2 root 3, because when I did that times that, I got that, which I shove here. Finally, to make it a bit neater, the bottom number needs to be just one value. So 25 minus 3 can obviously be simplified down to 22. So the bottom is 22, and at the top I've got 34 plus 2 root 3. However, looking here, I don't want anything in front of this root 3, so I don't have 2 root 3, I want just root 3 on its own. Finally, you'll see here, 34, 2 and 22 are all even numbers, so I can divide top and bottom by 2, and then that will give me the final answer we need. So half of 34 is 17, half of 2 root 3 is obviously just root 3, and half of 22 is 11. That's in the exact form we need, so our A is 17 and B is 11. Not that you need to say that, leave it like this, and you're done. You can now move on to the next one. We're getting very close to the end of the paper now. Question 20. We've got a diagram showing the graph of x squared plus y squared equals 30.25. Any graph where it's x squared plus y squared equals some number will always give you a circle. So in red, that's the equation of a circle. So I'm going to superimpose there that redness on top of the already given curve, which was a circle. Now, the next thing to think about is solving these two simultaneous equations. So the solution of two simultaneous equations on a coordinate grid is the same as working out where those two lines or a line or curve cross over. Where they cross over, the x coordinate and the y coordinate is an answer, it's a solution to that simultaneous equation. So we've drawn in the red, we need to draw in this blue line here, y minus 2x equals 1. Now that is going to be a straight line, however, the best way of writing a straight line is in the form y equals mx plus c. So if we made y the subject here for this one, what we'd have is y equals 2x plus 1. Now that's easier to picture. That's going to have a gradient of 2 and a y-intercept of 1. So let's start plotting on this. So for this one, y-intercept is at 1. If I go 1 along, I'd go 2 units up because a gradient's 2. So the next point would be somewhere here. It'd be 1 and 3. And again, you get the idea of where this line's going to go. So soon enough, you can draw a straight line through all these points, and it looks something like this. So now we can see where these graphs cross. We're going to cross here and there. So we're focusing in for these estimates for the solutions on these two parts here. That one and that one are going to be our solutions. So here you need to plot your graph as accurately as possible to get your best estimate possible. An estimate doesn't mean just guess and be really slack and lazy about it. Estimate means do the best you possibly can without knowing with 100% certainty. So read off these lines very, very carefully. The examiner lets you off to an extent, but not fully. So the first solution is where these 2 points crossing green, I've labelled them, and the second solution pair is here. So you can see here one solution is about x is 2.1ish and y is about 5.1, and this one down here x is nearly minus 3 and y is about minus 4.8. So the exact solutions to one decimal place which are ideal are these here. X is 2.1 and y is 5.1. Or for the second solution in purple, this one down here, x would be minus 2.9 and y would be minus 4.7. If you've done this question and your answers are slightly different and you're thinking, well, would mine get a mark? For this x value, it needs to be between 2.0 and 2.2. Your value of y to get the mark, it'd need to be somewhere in between 5.0 and 5.2. So plus or minus 0.1 from mine. Same here. If you're within 0.1 of either side of these two as well, you get full marks. If you're more than 0.1 away either side from my values here, that's not accurate enough to secure you the marks. So do draw the line as accurately as you possibly can with a thin pencil and a fresh straight ruler, please. So that's question 20 for you. Question 21, we're talking about composite functions and also function inverses for part B. Part A, we need to work out gf of 1. So the function f takes the input, squares it, times it by 3, and adds 1. So the input is just what's inside the bracket. So here, input's x, it spits out the thing you put into it, squares it, times it by 3, adds 1. The function g takes the input x, whatever x may be, squares it, then does 4 divided by whatever that thing squared was, for when x is bigger than 0. Here, gf of 1 means we do the function g to f of 1. You start from the outside and work backwards. So you're going to first of all need to do what f of 1 is. So what would f1 be? Well, f of 1, well, if the input was x, it'd be 3 lots of x squared plus 1. Be 3 lots of x squared plus 1. Whereas here it's going to be 1 squared plus 1, because rather than having an x in the brackets, we've got a 1. So it's like so. So now, well, 3 times 1 squared, do the brackets first. That means 3 times 1 times 1, which is still 3. 3 plus 1, which is 4. So therefore, gf of 1 that's the same as saying we want to work out what g of 4 is, because f of 1 is 4. So then it's just remembering what g does. So g of the input is always going to be 4 divided by what is in brackets squared. So here in the brackets wasn't the x, it was a 4. So instead of being 4 divided by the x squared, it's going to be 4 divided by this 4 squared, because 4 is in the brackets. Now 4 squared is 16, so we've got 4 over 16. That simplifies all the way down to a quarter. So gf of 1 is a quarter. Part B is, to be fair, a beast. So the function h is such that h equals fg to the minus 1, it says. This doesn't mean a reciprocal. This is a function notation. This means h is the inverse function of f of g of x. So what we need to do first of all is work out what f g of x is, and think about what fg inversed is, and that is our h. So f of gx just means we're going to input into f what g of x is. Well, all of g of x is 4 over x squared, so it's f of 4 over x squared. So in the f brackets now isn't just an x, it's all of this, sorry, wrong colour, it's all of this 4 over x squared. So what f does, we write down a 3, put the input and square it, so our input now is 4 over x squared. So it's all about squared and then plus 1. So what we can do here is times all this. So we've got 3, 4 squared is 16. And then x squared squared again is going to be x to the power 4, because x squared times another x squared is x to the power 4. And then plus 1. So now we can just multiply all of this by 3. So we just times the top by 3. 3 times 16 is 48. So it's 48 over x to the 4 plus 1. So that's what fg of x is. To find the inverse, what the best thing in my opinion to do is just call the original function, fg of x, just call that y. So y, as it were, is this, 48 over x to the 4 plus 1. To work out the inverse function, we make x the subject rather than y. And at the end, we're going to switch out the letters. It'll make sense when we do it. So, to make x as a subject, I need the x not on the bottom of a fraction, but on top of something. So in a moment, we're going to be multiplying by x to the power 4. First of all, the best bet is probably to just subtract 1 from both sides. So if I take away 1 from here and 1 from there, that will then give me y take 1 equals 48 over x to the power 4. I can then multiply both sides by x to the 4, so if we do that next, I'll then get x to the power 4 times by y minus 1 equals just 48. Then as a final step, what we can do, not doing very well with my colours today, and again, trying to get an arrow, there we go. I can now divide both sides of this by the bracket y minus 1. So if I divide everything by y minus 1, I'll get that x to the power 4 equals 48 over y minus 1. So then, to go from x to the power 4 to just x, opposite of x squared would be the square root. Opposite of x cubed would be the cube root. Opposite of doing to the power 4 is to do the fourth root. So x is the fourth root of 48 over y minus 1. We now switch the letters. So your final step, using this way I tend to teach, is the x, we're going to call this the inverse function. So here, that's our h. h is this inverse. So h equals the fourth root of 48 over, and just as we switched the x for the inverse, we replace the y with the x. So make two switches at the end, and as long as we do that, we're fine. So h equals the fourth root of 48 over x minus 1. Question 22, the very last question. So what we want to do here is to find the coordinates of a turning point on the curve with equation y is 9 plus 18x minus 3x squared. You must show all your working. To find the turning point of a quadratic, what this is saying, without saying it in words, is we need to complete the square. Completing the square essentially tells you the turning point. So it's a hidden question of completing the square. It would have been much simpler if it just said complete the square for this expression, but it didn't. So I'm going to show you step by step how I'd tackle this one. First of all, I'd rewrite this in descending powers of x. So put the highest power of x first. Write minus 3x squared, then the 18x, and then the number on its own at the end. To complete the square, we need to factorise out any number in front of the x squared. The coefficient of x squared needs to be 1. We've got this negative 3 in the way. So what we're going to do here, we're going to factorise out the negative 3 and factorise just the x stuff. That plus 9 we can leave alone. Don't worry about that 9. We're trying to factorise this x stuff. So I've got minus 3. I want to have minus 3x squared. So in the brackets, I need to pop in x squared. I've got minus 3, but over here I've got positive 18. If I take a minus and multiply it by a minus, that'll give me the plus. So that's why I need a minus sign here. And to go from 3 to 18, I need to multiply by 6. So my number needs to be minus 6. Because minus 3 times minus 6 gives me the 18, and that works. However, it's not just 18, it's 18x. So that needs to be minus 6x. So the first step is to go from this bit to that bit. Now we deal with the completing the square. So we complete the square on only the xy stuff. We don't bother with that 9, that can be left alone. We're just completing the square now on this bit. So the minus 3 and the plus 9 essentially we leave alone. I'm just going to deal with completing the square on this bit highlighted in yellow. So I'm going to put big brackets up now, and that plus 9 goes at the end. The trick here, to complete the square, once you've got 1x squared, we make brackets and just put a single x in. Whatever number's in front of the single x, in this case for -6, we just half that number. Half of -6 is -3. Close brackets and square. Then you always write a minus sign, and you minus off whatever this number is here squared. So whatever it is, it's going to come out as a positive answer. -3 times -3 is +9, so we minus off that 9. Now we can re-expand out. So now we can times it out again. So -3 lots of that. -3 times -9 is +27. Also got that +9 as well. Finally, we've got -3 brackets x minus 3 all squared. And 27 plus 9 is 36. Now, the numbers here tell us what the turning point is. So the x-coordinate at the turning point is this value inside the x bracket with its sign switched. So instead of -3, we put +3. The turning point is when this here is minimized. The minimum value of this bracket is 0, this bracket is 0 and x is 3. Then when x is 3, all of this is 0, so -3, lots of it is also 0, and we're just left with 36. So this number on its own is always the y-coordinate at the turning point. So it's 3, 36. That number gets switched, that number stays exactly as it was. So the turning point is 3, 36. That's question 22 and therefore the whole paper. I hope you found some of that useful. Maybe not always fun, but hopefully useful in getting you on the right track. So if you have found it useful, please do message, leave a comment, like and subscribe, all that jazz. I do appreciate you watching and listening. I hope it is useful, I'll say again. And best of luck with your revision and exams in the future. Take care of yourselves, and I'll see you in the next video. Goodbye for now.